Hello Math 1, I'm back with another video on factoring. This ride just keeps rolling along. This is probably one of the most fundamental things that you guys will learn in this part of factoring that will carry on into classes beyond this one. It's called factoring trinomials. Remember, trinomials were just three-term polynomials, and it requires kind of an interesting little clever move to get the ball rolling. So I left you guys off with factor by grouping, which required 4 terms to factor. And just to get a brief recap of where all this factoring business is coming from, remember, what we're trying to do is we're trying to create terms like, let's say 3x minus 7 times x plus 2. Okay? That's kind of like our end result. We want answers that look like this. All right? Now remember, here was the process for multiplying these out. We would always say, take 3x, rewrite it next to the x plus 2, because we're multiplying 3x times x plus 2. And then we're taking the negative 7 and multiplying that by x plus 2. If you multiply it through, you get 3x squared plus 6x minus 7x minus 14. And then I think a lot of times we think nothing of this final move when we're simplifying the other way with polynomial multiplication. It's just 6x minus 7x is minus 1x. Okay, here's the reason why I showed you that today. Not just to remind you of that this is the reverse of factoring, but to give you this essential reference point. 3x squared minus 1x minus 14 is a trinomial. If I were told to factor that trinomial right there, here's what I would have to do. I would have to figure out what is the 4-term polynomial that would allow me to do factoring by grouping. And remember, factoring by grouping doesn't just randomly work always. I mean, there is a very tight specified criteria to make this work. The 6x minus 7x was very precise, okay? And then once you get the right 4 terms, then you can move backwards and say group the first 2 together. GCF, leftovers, second 2 together, GCF and leftovers, and then it moves back there, and that's our final answer. So sorry if that was super confusing. Let me now extend this to the move that needs to be done in order for you to utilize your factoring by grouping skill set, okay? So right here we've got 10x squared minus 19x plus 6. So for comparison, I just wanted to show you that the 3x squared minus 1x minus 14 that we were kind of playing around with over there, when you rewrote it as 4 terms, you still had the 3x squared, and you still had the negative 14 at the tail end of this polynomial. It was the negative 1x that turned into 6x minus 7x. So the same thing here. What I'm trying to do is I'm trying to say this negative 19x needs to be split up into 2 other terms that, with factoring by grouping, it's like that those 2 terms need to share something with the ends. But they also need to add up to get the middle. 6 minus 7 is negative 1. So the question is, how do we do this? And what you can do is you can do this AC method for factoring. All right, let me explain what that is. AC, every polynomial, rather quadratic 3-term polynomial that has this, you know what, I'm not going to explain that too much right now. Just recognize that your A term is 10, your B term is negative 19, and your C term is 6. This is the leading power, the leading coefficient. This is the constant, and this is sort of like your middle term here. What we're going to do is we're actually going to multiply A times C Okay, multiply that and figure out what are the factors of 60 that add up to give me my middle term, negative 19. All right? So this can be very confusing to start off the bat. Let me just reassert this. We're using the numbers from the polynomial to create this chart. And when I say 60, finding the factors of 60, it's the same thing as day 127. Day 127 said find the sets of factors, and you guys, you created, it seemed like 2 long lists of factors. Like, hey, 1 times 60 equals 60. But here's the thing, 1 plus 60 does not equal negative 19, so that one doesn't work. These are what I'm talking about when I say sets of factors. So, negative 1 times negative 60 also gives us 60, but negative 1 plus negative 60 does not equal negative 19. So the idea here is we're finding the match of what multiplies to give me 60 and adds up to give me negative 19. And you know what? You can write the whole list of factors of 60 if you want to. I think there's quite a few of them. There's 2 and 30, negative 2 and negative 30, 3 and 20, negative 3 and negative 20, 4 and 15, negative 4 and negative 15, 5 and 12, negative 5 and negative 12, 6 and 10, negative 6 and negative 10. I don't know, am I missing any? I don't think so. I think I got them all. But the bottom line is only one of these sets actually makes the negative 19 happen. Can you guys spot it? Correct. It is the negative 4 plus negative 15. We've got a winner. Yes. Okay, so what does that mean? What does it mean when we finally get our winner? That means that we have successfully figured out what this middle term should be broken up into to create balance and then allow us to factor by grouping. So the negative 19x can be rewritten as negative 4x plus negative 15x. Okay? I'm literally saying, hey, negative 19, that's the same as negative 4 plus negative 15, which is a true statement. I'm actually going to rewrite it, though, where I group the 10x squared with the minus 15x and the minus 4x with the 6 on this one. So the commutative property, and I'm just going to say instead of plus a negative, I'm just going to say straight up minus 4x. All right, so take a breath. Again, this part of the process, it still might be a little confusing, but just please stay with me on this. So now what we do is we say 10x squared gets brought down. Here are our 2 middle terms, and now it's just a matter of use your factoring by grouping skills to take this polynomial, group the first 2, group the second 2, and then do your thing. So with this first group right here, the GCF seems to be 5x. Okay? So we divide by 5x now to get our leftovers. This is the one where we don't use our prime factorization. I actually think you should probably use this one and not the prime factorization anymore. The prime factorization is like the training wheels. It's time to take the training wheels off the bike. So then the leftovers, 10 divided by 5 is 2. X squared over x is x. 15 over 5 is 3. X over x cancels. There's a minus in between them. So 2x minus 3 are your leftovers. Over here, our GCF should be, well, first of all, it's a 2. But look, I've got a negative and then a positive. But I need a positive and then a negative. So I'm going to take that minus 2 out of here. so that I can divide both parts by -2 and create -4 divided by -2 is +2 with an x. 6 over -2 is -3. All right, taking that negative out was absolutely necessary to create the 2x minus 3. All right, our final move of factoring by grouping. I think I might have ran out of room here, but I think if we just erase a little bit, we'll be fine. So you had 5x times 2x minus 3. You had -2 times 2x minus 3. Your GCF was here and here. The two GCFs now create their own binomial. And then the leftovers, finish it out. Okay. There was a lot there. So now what we're going to do is, now that you're at least introduced to that first move that allows you to kind of figure out, all right, I've got this middle term that needs to break up into two other terms, I think we can start to think our way through more examples. So let's see what number 2 looks like. All right, so first things first, what I'm going to do is identify what A, B, and C are, figure out my AC, figure out my B, and then maybe start to make sense of that column. So, A equals 2, B equals +3. I should be very specific about positives or negatives. C equals -14. All right, so just using that chart. Make sure you have it in standard form, by the way. If it's not in standard form, it's not going to work out. Okay, so remember, your chart is on the left, AC. What multiplies to give me 2 times -14? -28. But also has to add up to, so multiplication here, addition, adds up to +3. So, maybe instead of writing the entire chart, the whole list of factors, maybe just think your way through it, or even if you got a calculator handy, just start taking -28 and being like, all right, a negative number has to have a negative times a positive, all right? So, 28, 2 times 14, those don't add up. You know what? On this example, I'll write them all out. So you got 1 times -28, -1 times 28. 2 times -14, -2 times +14. 4 times -7, and -4 times 7. Those are the only sets of factors for -28. You just got to ask yourself, which ones add up to 3? -4 plus 7 is +3. And it has to be -4 plus 7. It can't be 4 minus 7, because that's -3. It needs to be +3. So, we figured it out. You need a -4x and a +7x. So we rewrite the 2x squared minus 4x. It's going to be +7x minus 14. Factoring by grouping now, we're on like day 4 of this. So this is probably a lot easier than it was the first day you did factoring by grouping. 2x squared minus 4x, they both share a 2x. If you divide by 2x here, divide by 2x here, you get x minus 2. 7 and 14, you're going to have a +7 that divides them both. This is my GCF, so you get divide by 7, divide by 7. That again should match the x minus 2 here, which it does. Your last move is you make the two GCFs into one term. 2x plus 7, and then the x minus 2's.